Hello everyone, my name's Dr. Vile. Welcome to my A-Level Chemistry YouTube channel. The aim of this channel is all about getting you ready for your A-Level Chemistry exams. And with that in mind, we're going to focus in on titration calculations in this specific video. Now, not the most riveting topic perhaps, but it is really important. It comes up loads on your A-Level papers. So this is really important that we understand how to do the basics. In this video, we're just going to look at relatively straightforward examples, but I'm going to do subsequent videos on back titrations and on double titrations as well. So do check back for those at a later date. So if you find this video helpful, please like, please subscribe, please share with your friends. And what we're going to do is we're going to look at some examples and we're going to learn about how to do these calculations as we go through the examples. When you think of the word titration, basically what we're doing is reacting a chemical that we know the concentration of with a chemical that we don't know the concentration of. And by measuring the various quantities of the two chemicals, we can do some calculations to work out the unknown concentration. So in the example here, we've got hydrochloric acid reacting with sodium hydroxide, and you're given all the data in the question. Unfortunately, when you get these sort of questions, you get big chunks of text normally, and you have to interpret the numbers from the text. And can I give you a method that I think will be helpful for this? It's a table method for solving this kind of problem. So in the first column, I put the letters N, C, and V, where N is the number of moles, C is the concentration, and V is the volume. The second column and the third column, I'm going to put the two chemicals that are reacting together. So that's your NaOH and your HCl. For the purposes of this, the rest of the equation is irrelevant, but we need it in order to balance the equation. It's worth noting that 1 mole of sodium hydroxide is reacting with 1 mole of HCl. It's a 1-to-1 ratio. And then what I like to do is read through the question slowly and fill as much of the table as I can just from the question. So it says in the titration, 25 centimeters cubed of 0.100 mole per dm cubed sodium hydroxide solution. So let's just fill that in to start with. The volume of sodium hydroxide is 25 centimeters cubed. The concentration of the sodium hydroxide is 0.100 moles per decimeter cubed. And then we carry on reading. So in the titration, 25 centimeters cubed of 0.1 mole per dm cubed sodium hydroxide solution is exactly neutralized by 20 centimeters cubed of a dilute solution of hydrochloric acid. So the volume of the hydrochloric acid is 20 centimeters cubed. So we can fill that in. And that's everything that we've got from the question. And the aim of this question is to calculate the concentration of the hydrochloric acid. So the first thing we do, if we know the concentration and the volume of the sodium hydroxide, is we work out the moles. So to do that, we do N equals C times V over 1,000. And the reason we divide by 1,000 is because the volume is in centimeters cubed and the concentration is in decimeters cubed. So it's going to be 0.1 times 25, divide that by 1,000, and that comes out as 2.5 times 10 to the minus 3, and that is moles. Now, because these are reacting together in a 1-to-1 ratio, 1 mole of sodium hydroxide would react with 1 mole of hydrochloric acid. So if I've got 2.5 times 10 to the minus 3 moles of the NaOH, I'm going to have the same number of moles of the HCl. Now at this stage we have the number of moles and we have the volume of the hydrochloric acid. So what we have to do is take our equation that we've written over here and rearrange it to make C as the subject of the equation. So C equals N times 1,000 divided by V. So that's going to be your 2.5 times 10 to the minus 3 times 1,000 divided by 20, and that comes out as 0.125, and because it's concentration, the units would be moles per dm cubed. And that is your basic method of how to do a titration calculation. On the next example, I'm going to show you a slightly trickier one where the ratio isn't 1:1. What I'm not going to do on this video is go through how to balance equations. There's already a video that I've done on that. So please look that up if you don't know how to balance chemical equations. So in this reaction, you've got sodium hydroxide reacting with sulfuric acid. And notice that for every 1 mole of the sulfuric acid, it reacts with 2 moles of the sodium hydroxide. That's going to be important. So let's make our table, same as before, N, C, and V. And then you put the H2SO4 in the next column. And then 2 lots of NaOH in the third column. And then what we'll do is exactly the same as before. We'll go through and fill in everything we know from the question. So it says 25 centimeters cubed of 0.3 moles per dm cubed sodium hydroxide solution. So let's fill that in. So the concentration of the NaOH is 0.300. By the way, when I write moles per dm cubed, you can either write moles slash dm to the +3, which means the number of moles in a cubic decimeter, or you can write moles dm to the -3. It means the same thing. The volume is 25.0 centimeters cubed. Notice that all the data is given to 3 significant figures, therefore our answer is going to come out to 3 significant figures. So you've got 25 centimeters cubed of 0.3 mole per dm cubed sodium hydroxide is exactly neutralized by 0.100 mole per dm cubed sulfuric acid. So in this case, we actually know the concentration of the sulfuric acid. It's 0.100. And the aim is going to be to work out the volume required. So we start off in exactly the same way. N equals C times V over 1,000. So that's your 0.3 times 25 over 1,000. And that comes out as 7.5 times 10 to the -3 moles of the NaOH. Now this is the bit that people often struggle with. 2 moles of sodium hydroxide react with 1 mole of sulfuric acid. So to go from 2 to 1, we have to divide by 2. So it's going to be your answer here divided by 2, which is 3.75 times 10 to the -3 moles. It's half the amount. So now we know the number of moles and the concentration. We need to rearrange our equation that's over here to make V the subject. So V equals N times 1,000 divided by C. So So we can now start to plug some numbers in. So it's going to be the 3.75 times 10 to the minus 3 times that by 1,000, divide that by 0.100, and the answer comes out as 37.5, and that's millilitres or centimetres cubed, same thing. So that's your final answer, 37.5 centimetres cubed. Anyway, I hope that video was helpful. That's just an introduction to titration calculation. Do please come back in a subsequent video where we're going to look at how to do back titrations and double titrations. And I'm sure we'll do some redox titrations in another video as well. So if you found this helpful, please like, please subscribe, please share, and please keep checking back for more content. Thanks everyone.